Good morning, ma'am. I am Hema from Computer Science and Engineering Department, specialization in AI and ML. Now, my topic is decision trees. I am going to discuss about structure of the decision tree, working principle, pruning technique and its types, examples, advantages and disadvantages, applications about the decision trees, and then conclusion. Introduction to decision trees. Decision trees are a popular machine learning algorithm used for classification and regression tasks. They model decisions and their possible consequences in a tree-like structure. Their intuitive nature makes them easy to understand and interpret for various audiences. However, decision tree can easily overfit the training data, leading to poor generalization on unseen data. Structure of decision trees. A decision tree consists of nodes, branches, and leaves that represent decisions and outcomes. The root node is the top decision point, while leaf nodes represent final outcomes or classifications. Branches indicate the flow from one decision to another based on feature values. Here we can see the structure of the decision trees. It contains root node, decision node, leaf node. Components of a decision tree. First one is root node. The topmost node in the decision tree is root node. It represents the entire data set and is split into two or more homogeneous sets. And the second one is internal nodes. Internal nodes within the tree that represent decision points. Each internal node corresponds to an attribute test. And third one is leaf nodes. These are also called as the terminal nodes. These nodes at the end of the branches which provide the outcome of the decision path. For classification tasks, they represent class labels. For regression tasks, represent continuous values. And the last one is branches. Arrows connecting nodes representing the outcome of a test and leading to the next node or leaf. Working principle. Decision trees use a recursive algorithm to split data into subsets based on the feature values. Each split is determined by a criterion that maximizes the information gain or minimizes impurity. This process continues until stopping conditions are met, such as a maximum tree depth or minimum samples in a node. Here we can see the example of the decision tree. Should I accept a new job offer? When coming to the job offer, we mainly consider about the salary. Here the root node is salary at least $50,000. If you are okay with it, then go for the further process. Otherwise, we can decline the offer. Need for pruning. First of all, pruning it is a technique used to reduce the size of a decision tree and improve its performance. It aims to eliminate branches that have little importance, thereby simplifying the model. By removing these unnecessary branches, pruning helps enhance the predictive accuracy of the model on new data. Here we can see the perfect example of the true pruning example. In the left side, we can see an unpruned decision tree. It contains lot of branches which creates lot of confusion to decide and it looks like complex. At the right side, a pruned decision tree is there. In this tree, we can see it removes all the less important branches. It looks very easy to decide. If income is less than 30K, we can decline the loan. Otherwise, we can go for the further process. Types of pruning methods. Decision trees work by splitting the data into smaller subsets based on the most informative attributes, continuing this process until the subsets are sufficiently homogeneous or predefined criteria are met. This structured approach helps create intuitive and effective models for making predictions in various contexts. There are two main types of pruning: pre-pruning and post-pruning techniques. Pre-pruning technique. A common pre-pruning technique is setting a maximum depth for the tree to avoid excessive growth. Another technique is requiring a minimum number of samples in a node before further splitting occurs. Additionally, using a minimum improvement threshold for splits can help prevent the creation of splits that do not significantly improve the model. And we move to post-pruning technique. One widely used post-pruning technique method is cost complexity pruning, which balances tree complexity and training of error. Reduced error pruning is another method that evaluates the impact of removing each node on the validation set performance. Ultimately, effective pruning methods leads to more robust decision trees that generalize better to new data. Here we can see the example of a simple decision trees. Suppose we have a data set about whether a person will play tennis based on the weather conditions. The data set includes the following features: outlook, temperature, humidity, and wind. The target variable is the playing tennis. Here is a small sample of the data set. In the below table, we can see the data set of a person, whether he play tennis or not based on the weather condition. Here we can see the decision tree construction. We will create a simple decision tree based on the given data set. Here is an example of what the decision tree might look like. Here we can see the root node is the weather. If it is sunny, then we can go for the humidity. If it is high, we cannot play tennis. If it is normal, then we can play tennis enjoying. And overcast means cloudy. If it is cloudy, then we can play tennis. If it is rainy, we can further see the wind condition. Wind is weak, we can play tennis. If the wind is strong, we cannot play the tennis. Advantages of the decision trees. They are easy to visualize and interpret, making them user-friendly for non-technical stakeholders. Decision trees can handle both numerical and categorical data without the need for extensive pre-processing. They can capture non-linear relationships between features effectively. Here we have some disadvantages of the decision trees. Decision trees are prone to overfitting, especially with complex trees and limited data. They can be sensitive to slight variations in data, leading to different tree structures. Decision trees can struggle with imbalanced datasets, may favor the majority class. Here the main disadvantages in the decision tree is overfitting. How to handle overfitting means overfitting occurs when the decision tree captures noise in the training data rather than the underlying pattern. To handle overfitting, we have to use pruning. Both the pre-pruning and post-pruning techniques help reduce overfitting. And then we can go for the set constraints. Limit the maximum depth, minimum samples per split, and minimum samples per leaf. And then we can check the cross validation. Use techniques like k-fold cross validation to evaluate the model's performance on different subsets of the data. Here we can see some of the applications of the decision trees. Decision trees are widely used in various fields including finance, healthcare, and marketing. They can assist in risk assessment, customer segmentation, and medical diagnosis. Their flexibility allows them to be tailored for specific problems across industries. Conclusion. Decision trees are a foundational tool in AI, offering both simplicity and effectiveness. Understanding their strengths and weaknesses is a crucial for selecting the right model for a given task. As part of an ensemble or standalone, decision trees continue to play a significant role in AI application. This is all about decision trees. Thank you for giving this opportunity. Hope you like it.